Far too many AI and agent projects die as science experiments. We've read the headlines, we've read the reports, we've heard the podcast. AI and agent projects live in the lab, they impress at demo time, but we all see it. They never get into production.
And there's a lot of reasons to think about AI projects failing, very similarly to the way we used to think about data science projects, where you're running an experiment and going from the lab to the factory, as we used to say, is a challenge.
Absolutely. So, welcome to the Agentic Mesh podcast. My name is Eric Broda, coming from Toronto, Canada, and my co host is John Miller out of San Francisco. Our topic today, beyond agent science experiments going from the lab into production, just to set the context, far too many AI and agent projects are stuck as proof of concepts. They're science experiments, never getting out of the lab. We talk to clients every day, and here's some of the words that they're saying. We're in proof of concept purgatory. I'm dying the death of 1,000 proof of concepts. What is going on?
It's a challenge when AI projects are treated as purely technical projects. And I think learning more about how we've done data science projects, you start to realize that a POC is just step one. Then you need to pilot it. Then you need to go into production. And there are issues along the way. Eric, tell me about your thoughts about getting started.
Yeah, I think you had some very good points. I think we often do get confused or misled, perhaps, thinking that this is a technical issue when, in the words of some other authors, it's a socio-technical problem that we need to solve. It has technology elements, absolutely, but there's a lot of organizational elements too. Things like a lack of clear value proposition. Why am I building these agents and what's the outcome I want to achieve? Maybe I do have a value proposition, but I've never done it before. So I underestimate the amount of work, or I actually misunderstand how much it's actually going to cost. Maybe I don't have the skills to actually do it. There's a whole bunch of organizational aspects, but I think there's also a few common obstacles to success around the technology side. So you did touch on one of them, and it's a problem. There's four problems. The first one you kind of hinted at is what I call the problems of operationalization. So this is, how do I actually, let's start with the end game. How do I actually run agents in a production-like environment? There's not a lot of guidance out there on how to do that. And the world of agents is a little bit different. That being said, if my goal is to get something into production, how do I actually instrument my process so that I can actually move these agents into production? Because after all, this is a problem of scale. We don't talk about agents as in one or two or three. What we have is, depending on which pundit you listen to or which CEO, whether there's going to be millions or billions, as Andy Jassy said, there's going to be a lot of them, which really means, a manual or even a semi-automated process is not going to work. So these problems of operationalization, I think, is the first one.
Well, so let me clarify my understanding of what you're saying, because I think in the category of operationalizing AI agents, it can mean a lot of different things. And as you've explained, I think you said understanding and observing what's going on with 1,000 or tens of thousands or millions of things is actually a fundamental problem that we've seen before in technology. And it's not something new. The hyperscalers would say, well, since cloud native application development, we've started to solve, or we've already solved, many of the problems of operationalizing millions of things. So what's specific about agents that make it harder to operationalize?
Sure, that's a very good question. I think there's a few things I would say. There's definitely some players, the big ones you mentioned, Google, Microsoft, Amazon. They have figured this out. They deal with the problem of scale. They deal with millions of things. The problem is most organizations do not. Even the largest banks that I work with or largest insurance companies, there's very few things that they have millions of, other than customers, perhaps. And they're managed, there's entire organizations to manage those customers. There's very few millions of things that they actually, or even thousands of things that they actually have. So most organizations are not experienced in running thousands of things well. And when you think about how, go ahead.
Sorry to interrupt. I think the magic word is reliably. I know we were talking about that the other day, but there's a whole profession that emerged in the cloud native era around reliability engineering. And that became something that was well understood by the hyperscalers. But what you're saying is that companies that don't have the experience reliably deploying millions of anything wouldn't have that expertise in house.
You got it. You're kind of coming right to what I believe is one of the core, several of the core root causes of the problem. I mentioned there's four of them. So we've
Okay.
talked briefly about the problems of operationalization. You've hinted at the other three, well, the other two, and there's a third one, the problems of scale. And then there's problems of reliability in brackets as at scale also. And then there's ultimately, if you have scale and you figured out reliability, is problems of trust. How do I actually trust the outcomes that these agents are going to do? Because after all, if I have thousands of them running, they could have some pretty significant impact to my business. So those are the four problems that I see as and they are. I will admit that they're a little bit more technical than they are organizational. Although the trust element is a significant organizational challenge more than a technical challenge. So those are the four uh, that we're going to talk about now. Maybe John, if I could just start, why don't I? We've talked about the operationalization side, but I think you're going to see a few common themes. So let me just dwell on this problem of scale. And each of these problems, by the way, if they were simple to solve, they would be solved already. These are what we characterize, or at least I do, is they are hard problems to solve. So problems of scale. As I mentioned, it's not one or 10 or even necessarily 100. When you run thousands of something, or as Jassy says, or Jensen Wang, millions of these things, you have to actually think differently. Now, the good news about this is we have decades of experience in how to do this. It doesn't mean you have decades of experience actually doing, but we know we can look to Google, we can look to Microsoft, we can look to Amazon, we can look to research papers that do explain how to solve these things. These are problems of distributed computing. Now, when you have thousands of these things, there's different architectures that you can use. We tend to end up landing on microservices as the core architecture framework. And the reason we do that is because there's decades of experience on how to run these things, observe them, discover them, operate them, containerize them, and deploy them. So the problems of scale are a challenge because most organizations have not done it. It's not the fact that there's not research, architectures, designs that tell you how to do it, but most organizations have not had to do it and hence do not have the skills or experience to actually build things at scale. But that's what the agent world is actually going to demand, John.
You know, that reminds me of the era of big data. We don't almost never talk about that anymore because it's such a bad term. But at the beginning of the era of big data, we used to say that a 1 in a million problem will happen 1,000 times if you've got 1 billion transactions. So you need to design things to deal with large numbers. Get that that is a key component. I'm hoping that the infrastructure providers like the Googles and the Microsofts and the Amazons build the infrastructure to allow us to do things at scale. I think it's an area that took a long time for the technology industry to perfect. And I remember the story of Kubernetes, for example, where it has now become the de facto standard for the infrastructure for deploying lots of microservices, but it doesn't solve all of the problems. And I wonder what the Kubernetes for trust of AI agents will be, or the Kubernetes for privacy of AI agents, or, like there's a lot of problems that come up of scale that come up because agents that we're talking about are in some ways thinking, right? And when something makes a decision or comes up with a thought or a series of thoughts, it needs to be something that can be reviewed and attested to by a human, that what they're doing is accurate or reliable. I know it's a different topic. I think it's probably fits into trust and how you're thinking about
Yeah,
that.
absolutely does. But I think first off, yes. But I think in order to have trust, you have to have, there's an order of operations, if you will. You have to have something that you can operate. You have to be able to operate at scale. And the thing I want to talk about now, the precursor to trust, which I think the words you used, I want to come back to is that there's a problem of reliability. And again, this is another hard problem. So I want to come back to the analogy we had in our first episode where agents are like people. And we have figured out how to have what Walmart has 500,000 people or something. We found ways to have almost millions of, I think they have more than a million employees. We
I
found
think so.
ways. Yeah, I think we have ways. We have figured out how to allow organizations of 10,000, 100,000, a million to actually interact. So we do know how these things, how people can actually overcome these challenges. Well, the analogy is somewhat the same. Is how did we solve the problem for people? Well, we looked underneath the covers and we had to figure out how we could have these conversations and these long running conversations we call business processes. Well, we figured out how to do that. Maybe we have tools like email, we have Slack. There's a bunch of different ways that we figure. We have organizational constructs that allow us to manage decisions within boundaries and then delegate them upwards or downwards. So there's a lot of things that we've done on the people side. The interesting thing about it is when we think about these long running conversations or business processes, if you will, they're also stateful. We figured out when a person goes on vacation how to route around them and still continue the business process. Same thing for agents. When an agent goes sideways, doesn't do stuff, or is missing information, how do we restart that conversation? These are problems of reliability. When an agent hasn't got the information it needs, when a person doesn't, they phone somebody and ask somebody. An agent needs to think about, we need to think about that the same way for agents. There has to be a human in the loop, somebody in the loop that actually provides the information, kickstarts that agent as necessary. When people have a problem, there's normally a resolution process, root cause analysis. There's lots of books written on this. Same type of thing. When an agent goes sideways, there needs to be a problem diagnosis. These are all problems of reliability, and they get exacerbated at scale. And again, we figured that this out with people. We now need to apply it to agents, and we think there's a great analogy.
Now, I agree with you. I think that's a great way of thinking about it. And one of the things we developed as we scaled up organizations is we scaled up the HR department. And so I know you're not necessarily saying that we need an HR department for our agents, but it feels like some of the examples you gave require this organization that actually helps make sure that the care and feeding of the agents is taken care of in the same way that we manage human resources, we need to manage agent resources. So I see an analogy that I think you're trying to that you're drawing.
Yeah, absolutely. So I think that's an outstanding observation because I think it is exactly, there's some version of this that will evolve. So let me give you a few examples. If you're a software developer, you're probably using tools like Cursor. And underneath the covers, there's 5 or 6 or 7 agents, to use that term, doing these things for you, creating test cases, optimizing code, whatever the case may, creating the HR manager for those agents. It's a team, a small team, if you will. And when they give you a response, you look at it, maybe you integrate it into your code or not, maybe you reject it, maybe you say, go back to the drawing board, you went down the wrong path. You are effectively the team leader for agents. So the concept is not new. Again, the analogy is there and we're starting to actually get there.
It just reminds me of what it feels like when individual contributors, developers on a dev team get promoted to manager. A lot of people hate that because you immediately assume responsibility for the activities of a group of people that need specialized care and feeding. People have personal needs that aren't reflected in getting work done. And so I just wonder how we're thinking about each developer managing teams of people. Sounds like a lot of extra work.
Well, I think there's going to be extra work, but there's a reason why people created teams and then created organizations and created firms and stuff like that. And I don't know the exact specific research, but people have found that when you have, 7 to 8 people reporting to you, that seems to be the maximum, maybe the optimal. When you have more, the lines of communication break down, expectations aren't necessarily set properly, things break down. I don't know what the rule is going to be like for agents, but the bottom line is we're going to figure that out. But the structure and the mechanics around it, at least the analogy for those structure and the mechanics, seem to be sound as a good starting point. How they'll evolve, I'm not sure, but it's a good starting point. So one of the things that we see is this notion of agents. Just like people have teams, we call agents, teams of agents, agent fleets. And then what we have is fleets of fleets. Now, the interesting thing about that is just like in the data mesh world, we had data products and you had data owners. In the agent world, you have an agent owner, but we think that's a pretty small concept. You'd have a fleet owner, and then maybe a fleet of fleets. So the concept is, you can see, is it starts to mirror the way people actually manage teams and organizations. And I think it's a very powerful concept. I know the analogy will run aground at some point in time, but I think it's a very powerful analogy.
I agree. I agree. So, what are some of the other things that prevent AI POCs from getting into production? We've talked
Yeah.
about a couple of them. What else?
Yeah. We talked about operational ability,
Yep.
operationalization. We've talked about scale. We've talked about reliability. The last one that I think is actually crucial, arguably perhaps the hardest one to solve, is this problem of trust. Again, this is a hard problem to solve. And I think this is a multi-layer type solution, but I think there's probably a few things that I think you taught me a little while ago. Trust is kind of like the human, again, the human analog is a CEO needs to deliver an outcome reliably. At the top of the organization, trust is about predictability and repeatability at scale. There's no CEO, unless it's a very small company, that measures, individual tasks. Rather, they rely on teams of managers, for example. And what the managers do is they translate the low-level metrics that staff create, and they translate those or facilitate those to delivering the outcomes that the CEO requires. So there's a multi-layer of trust, and it depends, like many things, trust is in the eye of the beholder. And I think that's an important thing to actually understand because it formulates the basis for trust. Now, the interesting thing about this is we have analogies that we can work on. So for example, if we're talking about how do we actually recognize if we've delivered repeatable or delivered on the outcomes, there's this notion of certification and governance. These are topics that are well established, well known in the data world, for example. When we think about certification, well known in the real product world. In fact, I would argue that this is probably the best model that we may actually want to think about is I call it the toaster analogy, John. And this is story, a narrative about how we build trust in real world products. And in fact, we do this for millions of products every single day. They're governed under standards organizations that we've probably seen, know, and love. Underwriters Laboratory in the US, the Canadian Standards Association in Canada. In fact, if you lift up your toaster, you will probably see the Underwriters Laboratory logo there, which means your toaster is not going to burn your house down. And there's equivalent ones in Canada, there's equivalent ones in Europe and other areas. But here's the thing is we do this every single day. And the beauty of that is the process, the learnings, all that has been proven over not 1 or 2 decades, but I think 7 or 8 decades. This is an example where we can learn from. Bottom line, they have created what effectively is a delegated and federated governance model. And why do they do that? Because they have millions of things, not just toasters, electrical equipment, plumbing. They have millions of things that actually have to be governed and certified. So there's a lesson here for us when we have thousands or millions or tens of millions of real world products and we have a delegated or federated model. Maybe that's something we ought to think about for the thousands or tens of thousands of agents we ought to think about. But what does that actually look like? We have federated governance models literally in front of us every single day. The government is one. The US government is responsible for top level policies and execution of common things across all defense, for example, but they delegate stuff to the states. In Canada, we have similar federal government model, but things like healthcare are delegated to individual provinces because they believe they're closer to the action. I know it varies, healthcare varies across different jurisdictions, but it's an example we deal with every single day. This federated governance model is not foreign. We do it with real world products like toasters. We do it every single day with people. There's a lot of lessons here learned, John, that I think we should be able to apply.
I agree with you. The example of that I had heard that relates to underwriter labs here in the US is that when electricity became available and was being distributed to every household, they needed a universal standard. And that's where the industry came together created UL, Underwriters Laboratories, and made sure that there was a governance standard in place so that manufacturers could create products, like you say, that are governed by a standard of acceptable reliability so that they don't burn the house down. So I think you're right that that is part of the AI journey. Let's bring it back.
The obvious question is we have these real world analogs. How do we actually, I want to bring it to the next level. How do we actually apply this to the agent landscape? So if I wanted to build trust in agents or the agent ecosystem, what do I need to think about? Let's start from the macro level, governance and lifecycle management. Coming back to real world products, there is a process by which toasters are governed. There's a process by which electricity and electrical components are governed. There's specifications, there's accredited parties that participate, there's certifiers that are allowed to certify and put the underwriter's lab things, there's checks and balances, there's problem resolution. This is all part of real world product governance. My proposition, our proposition, is that that thinking needs to be applied to governance at the agent level. So there's a framework for governance modeled on, for example, the underwriter's laboratory process. The certification and compliance is delegated, but there's clear policies that things need to adhere to. Purpose is adhered to, and those have ways of being verified and validated. But even under that, in order to do that, you have to have observability and traceability. What are my agents actually doing? And can I actually trace their activity through the various different interactions that they have? And if I can actually have these agents running, they can do task planning. But if they task plan, how do I actually explain what they were trying to do when we actually started to see the observability and the traceability? What were they trying to do, and did they actually do the things that the right things that we are actually observing? The next layer, we're going, macro, a little bit more macro now, or micro rather, is there's a defined policy and purpose. Every agent must have a policy and a set of purpose and a set of policies that are verifiable and that govern the boundary around what defines good in terms of an agent's behavior. Now, we've talked about agents, their purpose and policies, but there's a definition, not so much a definition, but what constitutes an agent? Well, it's an identity. Every agent, like a person, again, we come back to the people analogy, every agent has an identity. And once you have an identity, you have a set of rules that govern access, rights, authorization, if you will. But if you put all these things together, I have an identity. I know who the agent is. I know what they can do. I've seen the boundary around what they can do. I can see the plans that they're allowed to create and the explainability about how they were thinking. I can observe their behaviors and I can measure that against a certification framework, all wrapped into a governance capability. That's the key. That's the lessons learned from real world product management that we need to apply to.
It seems to me we haven't really defined how to think about those agents. I wonder if it's worth going back and starting with the definition of an agent and what an agent can do. And when you talk about policies for agents, give us an example of what that could be. Is there an analogy for that we can use to build up this understanding of how to think about trust?
Yeah. Yeah, sure. If you let's do a real simple example. Let's say bank account open. And I know depending on what type of bank account open could be you're trying to open, it could be very simple or it could be very complex. But effectively, the purpose of the agent or set of agents would be to open the bank account. So verify an identity, do a know your customer, do an initial deposit, notify the customer. So that's the purpose of the agent. The policies, an example might be that if you're in Europe, they're GDPR compliant. Privacy in general, security in general, those would be documented in terms of policies. You may actually have boundaries around what systems and capabilities that bank account open agent may actually do. So, for example, if you're looking at an investment account, your policy would say you'd have to do a very review of a risk profile. Or if you're setting up a checking account, that's probably not necessarily required. So those policies define under what circumstances and what constraints an agent can actually execute its tasks. So those are just a few examples that we see out there in the real world. Now, one thing I do want to kind of highlight, and I think you touched on it earlier, John, is there's got to be some tools out there that we can leverage and use. So you highlighted one absolutely correctly. We see things like Kubernetes as fundamental to the operating environment for agents. There's a few other pieces that we can build upon. So we've mentioned earlier, and this is a kind of our proposition on the agent architecture view. We've talked about microservices. Why microservice? Decades of experience on discoverability, observability, operability. We ought to use them. We've talked about traceability, correlations. There's tools that allow us to actually do that. We ought to reuse as opposed to reinvent. There's large scale, reliable communication fabrics like the internet available by cloud providers that we ought to use and not reinvent. There's technology around creating boundaries for applications and agents, containerization, virtualization, for example. We ought to be using these things. And if we did containerization, we automatically lean towards things like Kubernetes, a standard operability and deployment environment that can scale at length. The bottom line in this is whether it's trust, whether it's reliability, whether it's scale, whether it's operability, there's lessons to be learned from decades of practice. And that's perhaps one of the epiphanies I've seen in the current agent architecture and some of the science experiments coming it all right back around is if you're not thinking about these things and leveraging decades worth of experience, you may actually be stuck with a science experiment that you cannot get out of the lab.